So my talk is titled Testing Kotlin Coroutines. In the title, I've got 3 words of things that I feel quite strongly about: testing and Kotlin and coroutines. And the subtitle is I Need a Time Machine, because who doesn't need a time machine? As I go through my talk, you can see why I need a time machine and how it helps me. So let's see, clicker, yes. So I work at Civic Technologies. The reason why this is relevant is because we had all of our native code written in Kotlin with lots of tests, and we use coroutine for our asynchronous work. And I was writing tests, and I ran into some troubles with writing tests, and then I started exploring some solutions, and what I'm presenting today are the solutions that I came up with. So this is a brief where we are, roadmap of what's happening in the talk. I'm going to give a quick speed run through coroutines, not so much all of the detail of the syntax, but just the pieces of coroutines that's relevant for the testing. Then I'm going to jump into Android and coroutines, why we use coroutines in Android, and then the particular problem, what I want out of it, and a fix. And then matching all of this, I have a demo. I made a toy app called Hello 8-Ball. And then the 3 kinds of things that I'm going to look at, particularly in the toy app, are fast and slow tests, flaky and predictable tests, and view model tests. So you don't need to remember any of the code. If the code is confusing, there's a full repo with all of the code and all of the samples in there that you can peruse at your leisure at a later date. So let's get going. So this is Kotlin Coroutines, a speed run. So if you say coroutines, there are various buzzwords that come up: lightweight threads, suspending, not blocking, structured concurrency. So the lightweight threads part, a thread on the JVM is actually quite a heavy thing to start up. So with coroutines, each coroutine doesn't necessarily start up its own thread, and they share the resources, so that's why they're lightweight threads. Suspending, not blocking, means that if you look at this picture here, let's see if this thing works. Yeah. So if you've got a thread like the main thread running here, if something calls something with a sleep, the equivalent of a sleep in a coroutine in, this needs to suspend. If it were a thread in Java, that would block everything, but this just suspends so that things can carry on running, and then this can join in afterwards and continue. So that's the concept with suspend. And then structured concurrency, I'm going to have it in a subsequent slide, but it's to do with the fact that if you start something off, it runs in the background. How can you get control of that again? Can you cancel it? What happens to that background activity? So the first thing I want to add for coroutines is, together with the structured concurrency, what they've defined is the concept of a scope. So the scope controls the life cycle of the coroutines. It's like a thing that holds coroutines that are running. They can be nested, and each scope can wait for the children coroutines that are running inside it, or nested scopes, to finish. It can also be used to cancel children coroutines that are running. And also, if something is defined on a scope level, then inside child scopes can inherit that. So this is the mechanism that they use to control the concurrency. So in this particular picture, you see the pink rectangle. That would be your application scope. All of the other scopes that run in your app will get killed if the application scopes closes down. So it will cancel all of its children. So even if you started off coroutines and they were running and you didn't keep any handle of any of the jobs, if the application scope goes away, then everything inside it goes away. So that is effectively structured concurrency. And so the effect of that is you don't get no spooky actions at a distance. So no more asynchronous tasks that finish and come back and try and do things in your app, and then the app doesn't exist anymore and you get crashes. All right, so I said on this slide that each scope, the nested scopes inherit the context of the parent. So what is a context in the sense of coroutine and scopes? A context, each scope has a context. It's the context that specify what threads are used in the context. So you can also specify an exception handler, and there are some other flags, but it's the dispatcher in this context which is important, because as general Android devs, I mean, we know we can start up threads, but what we actually want to do is we just want to have things that are on the main thread, on our main UI, or we want network things in the background, or maybe we want to do a calculation. So those are actually only the kinds of threads that we really care about. And so the context, you can say what kind of dispatcher you want. And out of the box, you get main, which is the UI thread. You get IO, which is used for network access or disk access. And then you get default, which I think they say is one thread less than the number of CPUs you have, so that you can never take control of the whole system. So that's almost the end of the theory. So in Kotlin, what they did is they have one keyword that gets added, and that's the suspend keyword. So you put suspend in front of a function if you want to be able to suspend inside it. And suspend functions can call other suspend functions. But if you've got a suspend function, you've got a coroutine to be able to call it. So if you look at this piece of code here, this is just straight Kotlin. We're in a main loop. So here we're not in coroutine world. We need to go from non-coroutine world, inside coroutine world, and come out the other side. So this run blocking over here is actually a coroutine scope, and run blocking is a way to build one of these scopes, and it has only one thread, so things that run inside here are blocking. And so if you look at it like this, our previous slide, we had the suspend function here with a delay in it. The next slide, we have this run blocking thread, and what it'll output is hello, and then there's our suspend function coming out over there, and then hello world. So that's the end of the speed run on coroutines. So on Android, why would we use a coroutine on Android? I mean, I have the obligatory blank slide, because here you can answer my question. Is anybody going? Yes. Okay, you can answer the question. So much less code. But why would we do asynchronous work? Why would we want to do anything asynchronously in Android? Block the UI. That's exactly it. Yeah. So if you click and it goes in the background, it might stop whatever progress indicator you've got on your screen. Okay, let's see. And therein lies the problem. Immediately you've got something running on the main thread, you've got something going in the background. And that means you've got code that doesn't run on the main thread, and you've got lifecycle aware components that also check the main UI thread. So this becomes difficult to test. So here's a test scenario. My tests are running on the test thread. I start off some of this asynchronous code over here. It's still running. The test finishes. So the test finishes before the code runs that I want to test. Tricky to test. So naive solution, put in a delay. Okay. So now maybe the delay makes it so that this finishes and we can test over there. But this is a potential time bomb. Okay. Because this is what happens. Locally, I get all green ticks. Now I'm on CI, the timing's different, and my build fails. So that is like immediately tests that are flaky. And then what happens? At the top of the test, we either write, this test takes too long because of the timer, or we say, ignore this test because it sometimes fails. So what do I want? I want the tests to be fast because I hate waiting for tests. I don't want any flaky tests, and I want to be able to run my tests on CI. 3 simple things. So the fix is a time machine. So the core of the solution is that I need to run all of my tests and all of my test code in one thread, one blocking thread. I don't want my implementation to know that it's running on a blocking thread, but the way that I run my test, it needs to be on one blocking thread because otherwise I can't control things. For the parts of the app that actually make assumptions about the main thread, for instance, the view model, some of the architecture components, they make an assumption about the main thread. For those components, I want to be able to swap that main thread out and make it be the same blocking thread that I'm running. And to be able to do this, I've got to inject the dispatchers, which is the next point there. I've got to control the dispatchers. So I need to make a way that my implemented code doesn't know the difference, but I control the dispatchers. So that's a question of the architecture. And then as a side benefit, if it runs on the JVM, if it's Kotlin and can run completely on the JVM and not on Android, then I can run it on CI and it runs quickly on my local device. So that's all good and well. Some of these things we could do before, but luckily Google has provided this experimental Kotlin X coroutines test library, which allows me to do run blocking test and has got some awesome dispatcher controls. And I don't care that it's experimental because it's only going to be in my test code. I'm never going to ship it. So, an overview of the library. What it gives me is it gives me fine-grained control on my dispatchers. It gives me a test coroutine dispatcher. It gives me this, where we had run blocking before, I've got run blocking test now. The other thing it gives me, it allows me to pause my dispatcher. So I can start my test, set everything up before any dispatchers are run. So my dispatchers are paused, and then I can literally fine-grained control, tick the time on inside the dispatcher. So as you can see, I can't go back in time, but I can certainly control the speed of time that I'm experiencing inside my tests. Okay, the other thing that you need to be able to control the main thread, what you want to do is you want to set the UI thread, the Android UI thread, to be this test dispatcher. So for all of my tests, this is just a little blurb in the beginning, I made a test rule where you set the main thread and reset the main thread at the end of the test. This isn't my idea, this comes from a Google Code Lab. So there's a test rule that when it starts, it sets the main thread to this test dispatcher, and when it finishes, it cleans it up. And it also gives that test dispatcher available for my tests. So that's if you're testing view models. So now, enough theory. Now I'm going to introduce the demo. So I wrote a toy app, which is called Hello 8-Ball. The idea is you type in a question, and then after an indeterminate amount of time, it will come back with an answer. So the other feature is that while it's thinking about the answer, it will display a progress. And it's also got some other hidden features. If you enter a single word, like hello, it will go off to the internet and find a synonym. If you type the word password, it will go off to the internet and find a password. If you type a number, it will do a huge calculation that could potentially take an inordinate amount of time and tell you if it's prime or not, because we always need to know if a number is prime or not. So that's the basic features of the app. Oops, okay. So the architecture that I used for this is standard architecture component architecture, but also particularly architected specifically so that I can test things properly. So I've got the activity with a view model, and then this question repository. Let's go over here and then I can show you. So this question repository is the thing that decides, do I look for a password, or do I go on the internet, or do I just ask the 8-Ball? So there's an interface over here, and these things all have their own particular way of finding the answer to the question, and there's one interface over here, and there's a suspend function going in over here. And at this point, none of these parts know on which dispatches they need to run. They just run a suspend function. And at this point, this node over here is the one place where there's a decision made which of the dispatches to use. So what we have is that we have the activity and the UI on the main. We've got view model that's kind of straddling over here, because if it wants to report back, it needs to be on the main thread, and view model actually knows about the main thread. So the view model, when we test it, we need to swap out the main thread over there. Here, question repository, if you run it by default, it's got a repository for the dispatches. It's going to run these things, the 8-ball, the prime number calculation on the default, which is the one thread less than the CPUs, and these ones, questions synonym and questions password, it's going to run on the IO thread. And over here, what I can do for the question repository is I inject the test dispatches in here. So question repository thinks that it's firing these things off on whatever dispatcher it needs to. By default, it will use these dispatches. But when I'm testing, I'm injecting those test dispatches at this point, at that node. Okay. Right. So this is the method inside the question repository. It ponders, it's a suspend function, and then it figures out from the question. It has a way to look at the question, figure out. And then here, this with context, over there, you see it says context provider default. This context provider is the thing that gets injected. So I inject either the default, the IO, or whatever other ones you want. And so it's just got a when that calls the correct thing on the different dispatches. Okay. So slow tests versus fast tests. Okay, this piece of code is the 8-ball, the actual 8-ball. And I've got in here a list of the answers, in the normal 8-ball questions. And it's got a suspend function. And over here, I've got a random number of seconds because 8-balls can't be deterministic. They have to have some randomness. It shuffles the list and it gives the answer back. So that's what the code is that I want to test. Okay, so I have two tests here. So this one, we're running blocking. We call the 8-ball to get the answer. And then I check that the answer that the 8-ball gave is in the list of answers. Now, if you look over here, you can see that this thing is like a few seconds that this can take. Okay, I'll click. So these two tests, this one's slow, this one's fast. And it's exactly the same test. The only difference is over here, I'm using this test coroutine scope with this test dispatcher. Okay. And then when you run them, this is what it looks like. So you can see the slow tests are all taking long, and then these quick tests are all super quick. And the reason for that is that the test dispatcher fakes out time. If you say go continue with the second, it's just going to go as quick as it can, because that's one of the features of the test dispatcher. So there's the first thing that I wanted. I wanted quick tests and not slow tests. And if I'm working with delays and I'm working with that and waiting for the actual time, the tests could potentially be quite slow. So my first checkbox has been ticked. So now the next one is flaky versus predictable tests. Okay, so what do I want to test here? I've got the view model. What I want to test is that if you type in a question, this thing doesn't spin. If you press this button, then this thing starts spinning. And then one day when the 8-ball comes back with an answer, this must go away, and the answer must appear. So that's the purpose of this particular test. Since it's a view model test, I've got to set some things up. Okay, well, maybe we'll just do the naive test first. So let's see if I can see. Yeah. Okay, so what I've got here, what I want to know is if I'm asking a question, it must check to see if it sets the loading. So I'm running blocking. I'm mocking the question interface. So this is pretending there's a fake 8-ball on the other side. There's the question repository with this question interface going into it. Here's my view model. That's the thing I want to test. Here I go, fetch the answer. And now here's that infamous delay. And then here I must check if this is loading indicator, if that is set or not. And so the question is, how long must this delay be? And of course, no one knows, and it's certainly going to make the tests flaky. So here are the view model tests that are less flaky. So the first thing I've got this test coroutine rule, which is the one that sets the main thread. Okay, next one. Oops. Okay. This is just a rule that's added for architecture components that makes sure that things run synchronously. Okay, here's the interesting part. So this test coroutine rule has this test dispatcher inside it. I take the test dispatcher and I make this test dispatcher provider. What it does is it swaps this thing in for all of the main and the UI and the default dispatchers inside there. And there I've got my context providers. And that's the context provider that I pass inside the question repository so that when it wants to switch, that it's actually swapping in that test dispatcher. Okay, so here's the actual test. So first of all, I'm running a run blocking test, which means I'm using the test dispatcher's run blocking test. And then the first thing I do is I stop time. I go pause. Now I set things up. Here I've got my question. This is a slow fake 8-ball that takes 5 seconds. Here's my question repository. I'm passing in this 8-ball that normally takes 5 seconds, and I'm passing in this context provider, which has got the test dispatcher inside it. Okay. And now I've got my view model, and I'll ask it a question. But remember that dispatch is paused, so nothing's running yet, nothing's happening yet. Okay. So the first thing I do, I check that before it starts running, that the is loading is not showing, right? So the is loading is false. Then I literally jump forward 1 millisecond, and I check that now the is loading should start. So I'm checking that it's started. And then I advanced on my 4,998 milliseconds. I check that it's still running. I click on 1 millisecond, and I check that it's stopped. So I can actually have that level of control to test exactly that is actually happening. And none of this is flaky. Okay. And it takes 355 milliseconds to run. So I've got 2 tick boxes. I'm quick and I'm predictable. Okay, there's all of the tests on the app with all of the timers and everything running sub-second. And the other benefit of this is since it's not flaky and it's running on the JVM, I can run it on my CI system. So what's next? If anybody needs steps to know what to do next, I would say add 1 test and make it run on CI. And then an important step is to inject the dispatches. You need to structure your code so that you can inject the dispatches, so that you can use the Kotlin testing library. And then I would slowly migrate the architecture to separate the Android or the coroutine code away from the other code. So on that other architecture, I had Android code at the top, Kotlin code at the bottom, and limited places where I needed to inject the dispatches. And then I would add more coroutine tests. References. All of my slides are also in the repo, so I'm not going to stay here. And then there's the repo. And I'll come back to that in a sec. And then questions.